Welcome everyone. This is the second experiment and it's transient one-dimensional heat conduction in the slab. And in this we use a slab made of aluminum and it's of size 50 cross 50 centimeters. And this is the density of 2700 kg per meter cube and with a thermal conductivity of 215 and Cp of 900. And what we do is the original temperature of the slab is 500. We heat it up to the 500 and we then suddenly immerse into a liquid of 100 degrees Celsius, and then we see the temperature fall until 1 minute immersion. And these are the sizes, and the thickness is, this is in meters, so 10 centimeters thickness. Well, we use transient thermal for this. Drag and drop the transient thermal, and first we have to give the engineering data, and there is only one material here, so it's aluminum. And it's aluminum, and aluminum's density is 2700 kg per meter cube. So density, right click, include property, and it's 2700, enter. And next we have thermal conductivity of aluminum, and the value of it is 215 watt meter square Kelvin, and it's meters Celsius inverse, so we have to change it to watt meter Kelvin, and the value is 215, so enter 215, enter. And the third property is Cp, and Cp value is 900, so we go to aluminum and Cp is here, right click, include the property, and here it's joule kg Celsius, and we have to change it to Kelvin, and the value is 900, so 900, enter. And these are the properties of the aluminum. That's it. The engineering data part is completed and you can exit it. And now comes the geometry part. Right click on it and new design mod geometry. In this we create the model. In this we create the rectangle of 50 cross 50 and extrude it to the 10 centimeters. Yes, we select the XY plane, right click on it, look at, so it comes perpendicular to us. Now you select the new sketch and we go to the sketching part, create a rectangle, and you check for P so that it selects the point horizon and draw the rectangle. And now we give the dimensions. This is h1, then this is v2, and we know, and these both are in meters and we have to change the units to centimeters. Now this is 50 centimeters and this is also 50, and to make it proper you use this zoom to fit. Now you have to generate, it's done. And finally we have to extrude the part, so we go to the extrude and we select the sketch one, apply, and you can do either add material or add frozen, it doesn't matter. And the depth is 10, enter. And now you generate it. You can see it in isometric view. It's 10 centimeters. And yeah, now design modular part is done. You can close it. Now we go to the model part, right click on it, edit. Well, in the model part we give the named selections for wall 1, 2 and 3, and also we insulate the wall 3 Well, it's gonna take a little time. Yeah, okay. And now it has to upload the geometry into the model. So it's doing it. Yeah, you got it. Okay, first we have to assign the solid, the material, and this is the aluminum. So we assigned the body the properties of aluminum, what we put it in the engineering data, and it's done. Now we have to give the named selections. This, okay, we select the face, click N. This is wall 1, enter, and the backside, click N, wall 2, and now we have to select 1, 2, and the bottom two surfaces also. So click, hold the control button, click again. Now rotate it, again click the control button. Now click the rest of the two surfaces. Now you can see the four surfaces are selected, and you can now click N and give it as wall 3, enter. Okay, so yeah, we have named selections wall 1, 2, and 3. Now we have to generate the mesh. Generate mesh, and okay, we forgot the sizing, and span angle center we have to set as fine. Okay, now generate the mesh again, or you can also update. Okay, now in the transient thermal, insert convection, and we keep the convection, and we keep the scoping method as named selection. And for wall 1, the film coefficient is 1200, and the ambient temperature is 100 degrees Celsius. As we are putting it in 100 degrees liquid, so it has to be 100, and enter. And this is for wall 1, and we also have to give it to the wall 2. So convection, scoping methods, named selections, and wall 2. The film coefficient is 1200, enter, and ambient temperature is 100 degrees Celsius, enter. So we gave the convection part, and we have to insulate the rest of the surfaces. So right click, insert, and perfectly insulated. Now scoping method to named selection, and we give the named selections as wall 3. So we insulate the whole, rotating a whole leftover surfaces, and yeah, and the input is all done. Now we have to give what are the outputs. So insert and temperature, and right click, insert thermal, total heat flux. And for the initial temperature we have to set it to 500 degrees Celsius. And also in analysis settings we have like in order to calculate for the 60 seconds we have to set this, and for this part these are the steps. Like the step and time is 60 seconds, like it's the 1 minute, and you have to make the auto stepping on. So auto stepping on, step and time 60 seconds, and defined by time, and initial step and initial step is 0.6, minimum time step 0.06, and maximum 6. So initial time step 0.6, maximum 6, minimum 0.06, enter. Mm, yeah, that's it. And now right click on solution and solve. Well, solving it takes a little bit time. Okay, now the solution part is done, and we have the temperature, and this is the temperature result, and you can see the red is the maximum and the blue is the minimum. And this table here is, it tells like the minimum and the maximum temperature at what time until the 60 seconds, from 0.6 seconds to with a small steps until the 60 seconds. It gives the minimum, maximum and the average temperature, and this is the graph. And you can see it starts at 0.6 seconds and its average temperature is 493.87 degrees Celsius, and after 60 seconds came up to 330.36 degrees Celsius. This is regarding the temperature. And in the same way we have the total heat flux from 0.6 seconds to 60 seconds, minimum, maximum and the average values. So that's it, the solution is done. This is the temperature part, and this is the total heat flux part. Thank you.